Welcome to today's Roundtable webcast, brought to you by ERwin Inc., Looker, and HVR. I'm Stephen Fegg, Director at Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled, Building a Modern Data Architecture. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, one lucky viewer today will win a $100 American Express gift card. The winner will be announced at the end of the event, so stay tuned to see if it's you. Now, to introduce our speakers for today, Danny Sandwell, Senior Product Marketing Manager at ERwin Inc., Bruce Sandell, Senior Sales Engineer Alliances at Looker, and Mark Vandeville, Chief Technology Officer at HVR. For more information on our speakers today, you can click on the arrows next to their headshots. Now I'm going to pass the event over to Danny.
Hey, thank you, Stephen. And thanks, DBTA, and thank you to you all for the chance to share today. I want to apologize up front if you hear my squeaky chair. You will understand that if you had me sitting on you all day, you would be squeaking as well. So let's start out first, kind of set a baseline, just who we are at ERwin. Some of you may know us as the data modeling tool that could, and the data modeling tool that's been around and leading the industry for a good long time. But we were recently divested. We are now a standalone private entity, and we are building a solution really focused on model-driven data management, enterprise architecture, and data governance. And also thank you to DBTA for our recent re-inclusion in the DBTA 100. So as we look at building a modern data architecture, you know, the key things I think to think about is what's driving us. Why are we thinking about this? Why would we invest in a modern data architecture? And I think it comes down to something called the data-driven enterprise. When we look at the data-driven enterprise, it's really a change in the overall culture and approach of organizations in terms of how they view data, how data fits into their organization, both from a day-to-day perspective as well as a strategic and forward-looking perspective, as well as you know, how they treat data in terms of a part of their business, and really looking at it now as a strategic asset that can have a lot of power, contains a certain amount of risk, and really can be the key to the transformation of that business to this new world that we live in and this new economy that we all need to thrive in. So when we think of that and when we look at that from a cultural perspective, it's important to keep those drivers in mind, because truly we will be, you know, looking at a data architecture not just from a functional or architectural perspective, but also from a cultural and motivation perspective as well. And when we look at, you know, building a data architecture in today's world, there's lots of things to consider. There's a lot of drivers, you know, whether it's you know, move to the cloud, this concept of business self-service, the proliferation of off-the-shelf applications that are available and now really taking a center role in terms of the architecture of an organization. And there's lots of opportunities both from a technology perspective as well as a business perspective in terms of how we use that data and the technologies that we can you know, deploy and employ to get the most out of that data. And all of these things are really key to us to consider as we look at a modern data architecture, because you know, not everybody is greenfield, not everybody can rip and replace. Every organization is different and is somewhere along a continuum of a journey towards this new world. And really, those things really are opportunities, but they have to be opportunities that are well understood and of course, have the impact that's expected and to justify taking these steps in the organization. Before we dig into the concept of building a modern data architecture, I really wanted to talk about data architectures in general because there are different types, different kinds, and different levels of abstraction when it comes to architecture. I think both are equally important. One feeds the other, and then, conversely, one enables the other. So that data architecture, as it comes down to the meat and potatoes of what data is in your organization, how it flows and interacts with your organization, is very key. But at the same time, how you're able to take that data architecture and manipulate it for the needs of today, tomorrow, and the day after that for your business in the context of a larger organization is equally important. And at ERwin, we really feel that it's important to have both of these types of data architectures and really have them become one so that you can leverage those to serve the business, to deal with all the issues that data may represent to your business, but more importantly, to really get your arms around taking that data architecture, ensuring that it's flexible enough to meet those needs, and really allows you to take advantage of the opportunities that data represents to your organization moving forward. So with that in mind, it's really important to think not just about what is the data architecture, but what are some of the characteristics of a modern data architecture. And there's a number of them, and they're all important, and they all really work together to ensure, at the end of the day, the organization has trust in the data that you provide so that they can leverage that data, utilize it, and get the most out of that data moving forward. So it needs to be business-driven and aligned to the business. The days of building things and putting things together based on the constraints of technology or the capabilities of technology alone are long gone. They all need to be able to be tied back and easily and visually and understandably mapped to the business to make sure that when we do things and when we make decisions, whether it's a technology decision, whether it's new data added to the portfolio that exists in your organization, that we clearly understand how it is aligned both to the business operations as well as the overall strategy. It needs to be integrated, right? Integrated, data islands are just a problem that's waiting to happen. You need to deal with them, and you need to deal with them up front, because if you deal with them past that, it's going to be very expensive. It's going to be, bound to cause trouble, and you're not going to get that full capability because you're going to start making compromises in order to deal with some of those issues of integration if they're not clear, visible, and planned for up front. It needs to be agile. The world we live in, the business environment that we're in, is very agile. It places a lot of requirements, both in terms of capability, but also in terms of velocity. And things that are important and successful today, the landscape can change very quickly, and then suddenly they're not that appropriate. So it needs to be able to be nimble enough to move and meet those requirements. You need to mitigate the risk. So an assured architecture, one that is not going to land you in a jackpot. With this data-driven enterprise, people are betting the farm, and the level of the bet that they're putting on data is huge. So being able to squeeze the risk out, identify the risks up front, and mitigate those risks before they actually have an impact is clearly important. Equally important is understood by the business. Because if it's not understood, if people don't understand the data architecture, if they don't understand the elements of the data and how they hang together, how they rely and impact each other, then again, that goes directly to trust as well as the ability to use that data appropriately. So it needs to be governed, because data governance is really about applying the rules, ensuring that you have the rigor in your data architecture, but data governance is equally about ensuring that you push out and make your stakeholders in your organization good data citizens that are fluent in the data that they have in front of them. And then, of course, it needs to be predictable. They need to understand where it is today, where it's going, why it's going there, and then how it's going to impact them. Really, to achieve this, you need that rigorous blueprint, and that blueprint really has to have a lot of detail, a lot of rigor in it, but it also has to have clear perspectives and different contexts because, again, decisions that you make in the data architecture should be driven by strategy and motivation. They will also have implications across your business, the processes that are involved there, as well as all of the applications and technology that deliver the data to the organization and manage it under the covers. So without that round and holistic perspective on the enterprise and how data fits into it, that data architecture will be limited in its ability to meet all of those characteristics that we described prior to this. Which takes us to the ERwin Data Management Platform. Our vision is to bring you a all-in-one platform that takes all of these key elements, provides you, capabilities and skill, and ability, accelerating your time to value in any of these domains. But more importantly, really the ability to integrate these things together, to take value out of the things that you build, so that you can have all of those different perspectives, so that you can have the context and the map back to all of the key things that are going to drive your decisions in a data architecture moving forward. And that really drives a framework for the data-driven enterprise. You'll see at the top there are outcomes that the business, that the C-level people in your organizations are defining for your business. And then from that, driving behaviors in your organization around data, how data is used, how data is perceived, how data is managed. And then the key domains that come together to build that enterprise data architecture. So whether it's looking at strategies, motivations, goals, whether it's applications, technology, infrastructure, security, all of that is key to the data architecture. Changes in the data architecture are going to affect that and need to be driven by that. And then the same on the business side, understanding how data fits into the business so the decisions you make do not disrupt that business. And then allowing the business to drive your behavior and drive your decisions in that data architecture based on clear measures, based on clear key performance indicators, so that you really understand where am I getting, basically the bang for the buck in terms of my investments, where are my deficiencies, where are my opportunities, all on a good standard set of measures so that one can be measured and compared to the other, and decisions can be made in terms of how we can move this forward. So from the ERwin perspective, the content, the structure of the data architecture is key and important, but how you can manipulate and manage that architecture over time, expose that to the rest of the stakeholders in your organization so that everybody is bought into and understands what you're doing and can then make the plans that they need to make so that we are, again, walking in lockstep in terms of transforming our business into a data-driven enterprise. So with that, if you have interest in learning more about what we're doing at ERwin, our approach to data architecture, data management, and really building the data-driven enterprise, please come visit us at ERwin.com, follow us on Twitter, connect with us on LinkedIn. We would love to continue the conversation. So with that, I will say back to you, Stephen.
Fantastic. Thank you, Danny. I'd like to introduce our next speaker today, Bruce Sandell, Senior Sales Engineer, Alliances at Looker.
Hi, everyone. Thanks, DBTA, for hosting this roundtable, and thanks to all of you for participating. Stephen said, my name is Bruce Sandell, and I'm a Senior Sales Engineer at Looker. So first, a little bit about Looker. Looker is a modern analytics platform that lets anyone view, explore, and act on the metrics that drive your business. The company was founded a little over 5 years ago, and we now have over 900 customers. We're funded by some of the most respected names in the business. We have over 300 employees and offices around the world, with more employees and more offices on the way. We are a very partner-focused company, so if you think that your company provides complementary products or services, we'd love to hear from you. And our team at Looker is full of expertise in working with huge volumes of data to produce business-critical analytics. So the first question to ask when considering an architectural change is, why bother? Why bother changing your architecture? What's in it for you and your company? You've undoubtedly invested thousands of man-hours and millions of dollars into your current data infrastructure. So why would you move away from that? Well, if your company has been around for a while, chances are good this is a fairly good representation of your current data infrastructure. It's a complex series of point-to-point interfaces, workarounds, hacks, and band-aids put in place to work around significant technology and cost limitations. It's fragile and requires constant maintenance. But it's just the result of the evolution of data architectures. So let's take a brief look at data architecture evolution and see how we arrived at today's modern data architecture. At Looker, we've classified this evolution into 3 waves. In the first wave, databases were designed for transaction processing, not for analytics. Complex BI tools had to be designed around slow databases and expensive storage. These tools weren't built for end users. Data experts were needed to satisfy user reporting requirements. One benefit of this was that data governance and reporting accuracy were stellar. Only the people who knew the most about the data could produce reports. But soon the request for reports overshadowed the ability to provide them in a timely manner, which led to data bottlenecks, people waiting weeks or longer to get access to the data they needed. The second wave began in response to the data bottlenecks. It was based on segregated departmental data silos and the tools designed to work with them. Data sets were very limited. If you didn't have the data you needed, you had to get creative about how to acquire it. If a friend had a spreadsheet that might have the data you needed, that became the new definitive source. So reporting requirements were met more quickly with these self-service tools, but data governance took a back seat, which led to data chaos. This is when users from different departments would produce reports for the same business metric, but have significantly different results because they were grabbing data from wherever they could find it, or even defining the metrics completely differently. Was the data complete, accurate, or timely? Who knows? The result was often more time spent arguing about data than acting on it. So what's the solution? Is it possible to design a data architecture that is based on highly governed data and provides the agility of the self-service reporting silos and the accuracy of the reports produced by data experts? As it turns out, while the second wave was in full swing, there were groundbreaking technical innovations going on at some of the most respected technology companies in the world. A new set of technology that was no longer limited by slow database performance or expensive storage. A new computing paradigm born out of necessity from companies like Yahoo, Google, Facebook, and LinkedIn, whose main asset was their data and who needed to quickly process and derive value from those incredible volumes of data. New technologies like Hadoop, Spark, massively parallel processing databases, based on concepts like commodity hardware and elastic resource allocation, were built with high-speed analytics in mind, which changed the landscape entirely. And this led to the third wave of the modern data architecture. Whereas the 2 previous waves were characterized almost entirely by the need to work around existing technology and cost limitations, the third wave requires a new way of thinking. Without the technical and economic limitations that have been imposed on data teams, their roles shift from heads-down report creators to educators and enablers. You can eliminate data silos to provide users with a comprehensive view of what's happening and how it all interrelates. Rather than having to figure out what data can be ignored to reduce storage and processing time, you can now focus on identifying all of the ignored and forgotten data sources that can add real value and then help users maximize that value. You can look outside your walls for data that can help users make better decisions, social media, weather, whatever impacts your business, and look for new ways to enable not just your internal business users, but customers, partners, and suppliers to access data that makes them more efficient and effective. You'll develop a common language, a common set of metrics, and a data dictionary that enables users to ask and answer their own questions. It's data governance for the masses. You'll help users gain a greater understanding of data and how to use it. You'll teach them to fish rather than fishing for them. And best of all, you can focus less on the mundane management of technical resources, developing point-to-point interfaces, reverse engineering data models, or figuring out data access APIs. You can focus more on empowering users by making data easier for them to access, understand, and generate real business value. Instead of having the data experts working on a single report for a single user, the experts now work within a reusable model that can be shared by everyone. In other words, a modern data architecture is defined not so much by a specific technology stack, but rather by the organizational impact that it enables. Here's a view of the Looker view of the modern data architecture. At the bottom of the diagram, you probably have data living in lots of different places. You might have SaaS applications like Salesforce or Zendesk, data in transactional databases, and ERP and web analytics tools. It used to be that you had to extract, transform, and then load that data into your warehouse. And that transformation step was usually complicated and heavyweight, so you'd end up with a lot of logic baked into the transformation, making it very inflexible. But because of new fast databases, you don't need to pre-transform data anymore. Lots of the partners that we work with can make the process of extracting and loading data into your SQL data store practically plug and play. And once you've done that, you can shape the data to be the way you need using today's fast, cheap databases. And that's what Looker provides, a platform that sits on top of your database. The platform contains your data models, which give you that governed transformation, but in a really flexible, agile way. So once your analysts have gotten the information about what your data means out of their heads and into Looker, they're no longer a bottleneck, because now anyone in your organization can answer their own questions through Looker. You can use our own native visualizations, scheduled reports, and triggered alerts. You can embed Looker inside another application or access the data from your own applications using our REST API. And because all the questions pass through Looker, you'll always know that you get the correct answer. So back to our original question, why bother? Because a modern data architecture allows you to maximize the value of your company's greatest resource, the curiosity of your employees. If you're interested in learning more about Looker and how we enable modern data architecture, please feel free to contact us. We'd be excited to talk to you. And thank you all for your time. So back to you, Stephen.
Thank you very much, Bruce. All right, so at this point in time, I'm going to introduce our final speaker today, Mark Vandevelde, Chief Technology Officer at HVR.
Thank you very much, Stephen, and thanks everybody for attending today's webinar. My presentation is going to talk about continuous data integration, because if we think about modern data architecture, we think that continuous data integration is an integral piece of the modern data architecture. And why is that the case? Is because continuous data integration is a necessity to enable prescriptive analytics. So let me explain the concept of prescriptive analytics based on an example. But before I start talking about the example, with that picture on the right-hand side as a reminder to it. Let's just talk about a little bit about the evolution of business intelligence and data warehousing and where we are today. So back in the 1980s, 1990s, we started with building reporting systems to basically develop descriptive analytics, to find out what happened. That then eventually turned into more diagnostic analytics of figuring out why did it happen, which then over time led to more predictive analytics, is to be able to find what will happen. Prescriptive analytics goes beyond predictive analytics. It's once you know what is going to happen or what is likely going to happen, how can you then impact your operational processes in order to take action to make sure that things are going to happen the way you want it. So with that, let me just talk about the example based on a locomotive. A locomotive is a very complex piece of technology. It's built out of multiple parts, and all these parts interrelate. And if we think about modern data architecture, of course, some of us on the call, I'm sure, will think about Internet of Things data, sensor-generated data, data that gets generated by devices. Now, if you think about a locomotive, a modern locomotive will have literally hundreds of sensors that all output data at a pretty high frequency, all monitoring what is going on in the complex engine that is the locomotive. Now, that information is very valuable because the patterns across that data will allow the owner of the locomotive to operate this piece of equipment as efficiently as they possibly can. And with that, they can generate incremental revenue because just increasing the speed of a locomotive by just 1 mile an hour on average can make millions of dollars, literally, for a transportation company. So that information is interesting, but if you think about the manufacturer of the locomotive, they of course have a significant interest in that kind of sensor-generated data as well, because that data of course would be used to identify the operational performance of the equipment, but also it'll help identify potential issues that will be happening down the road. Now, when we think about prescriptive analytics, we think about how the manufacturer of a complex piece of equipment like a locomotive can influence its operational system, i.e. the manufacturing of parts of locomotives, by looking at sensor-generated data and essentially close the loop between, IoT data and then the operational aspects of how the organization works, i.e. let's make sure that the supply chain is well aware of potential issues that come down the road. We know that based on the locomotives that we've sold, that a significant number of those are going to need preventive maintenance within the next few months. We will track where those locomotives go. We'll make sure that the parts get manufactured in time, so any production line adjustments that need to be made are going to be made in time to produce the parts, so that instead of having downtime of an expensive piece of equipment, we're going to make sure that this piece of equipment continues to run as efficiently as possible, and we're going to service this with the right level of engineer at the right time to prevent complete outages. And that's what we mean when we talk about prescriptive analytics, is we're closing the loop on the data that gets generated and how we use it for operational analytics. So now if we think about, well, how do we build a modern data architecture around this concept of prescriptive analytics? Well, first of all, let's look at some of today's opposing forces. On the one hand, we're looking at more data sources, IoT data, or for some organizations it might be social media data. We heard from the other presenters, there's all kinds of different data that might influence the operation of your organization, whether it's weather, whether it's the the sentiment of certain comments on the internet. Could be all sorts of different sources that are now suddenly relevant to the organization that might determine whether there's churn coming up, whether products are going to fail. That's going to determine the likelihood that customers are going to move on. There's more data types per source, there's more data silos. So whilst we're dealing with all of this more, at the same time we're also dealing with less. We've got smaller batch windows. Almost every organization, or maybe I should say every organization, is represented on the internet, which makes everybody 24/7. We're dealing with smaller IT teams. So whilst we're dealing with more data and more different types of data, we've got to deal with those challenges with fewer resources, with less time to deal with it. And then whilst we're facing all this, of course, we've got a more demanding audience. Now, from the perspective, of course, of Looker, that's great because it's all self-service, but the demanding audience wants more frequent analyses, they want faster decisions, and they want better predictions. So how do you combine all of that together? And frankly, what role does HVR play in that entire spectrum? So if you think about some of the opposing challenges that we're facing, then it's really, when you think about this, you really want to look at continuous data integration. If you look at some of those traditional data sources, whether it's ERP systems, traditional relational databases, file systems, web applications, software as a service, how can we move that data on a continuous basis in a way that it then becomes accessible in a performant architecture for the end user so that they can serve themselves on data exploration and essentially generate revenue for the organization. HVR enables continuous data integration in a heterogeneous environment. The technology supports a variety of source and destination technologies, and with a modular architecture, it's a mix and match of the source technologies and destination technologies. And organizations use a technology like this to build modern data architectures, to build what is often referred to as data lakes, environments where data gets consolidated, not necessarily manipulated on the way in, on a technology that scales well, and whether that technology is still a relational database technology, a scalable one, or whether that is more of a file system-like technology like a Hadoop or maybe an S3, is almost irrelevant, because from the perspective of the technology, we can mix and match all of these different types of systems. So let me talk to a particular use case. So we actually work with a global organization that has the kind of challenge that I discussed when I talked about the locomotive. In fact, this global manufacturer not only manufactures locomotives, they manufacture a lot of other complex industrial technology as well. And as they centralize all of their data and as they work on models to perform the type of prescriptive analytics that I discussed, they also have the need to obviously integrate a lot of, call it more traditional data sources into that same data lake as well. And these are traditional ERP systems, lots of them, whether it's the Oracle e-business suites or the SAPs of the world, or whether it's more industry-specific ERP systems. There's SaaS applications. There's lots of different systems running on lots of different technologies, and all of that needs to be continuously integrated into a data lake. Now, that's a pretty significant challenge, because if you think about, for a moment, the kind of technologies that are being used, you think about source applications, and you think about, well, arguably very busy transactional applications, and you think about that kind of a workload, And then you think about, well, what technology is scalable for a data lake. It's not necessarily a fast transaction processing engine. So you want to do something like this efficiently, because any single source system could arguably bring down the destination system if you don't apply those changes well. And in the case of this particular customer, we're literally talking about hundreds of systems feeding a central data lake. So now the various source systems are very much in different divisions, different geographic locations, and everything needs to be centralized. And then, of course, that data integration also needs to happen securely as well, whilst at the same time, again, there's the IoT data that gets fed into this system as well. So, of course, for this particular use case, like I alluded to, the client decided to deploy HVR and use very efficient log-based change data capture on very many different technologies in order to take the data efficiently off of the source system in order to be able to propagate it into the central data lake. And then, of course, on the data lake side, we're applying optimizations relevant to the actual technology that was selected in order to make sure that we don't overload that data lake when, again, any single source technology system would be processing so many transactions that the data lake wouldn't even be able to deal with it. Minimum impact on the source, maximum efficiency on the destination. We think about, well, think about the scale of this. You've got hundreds of systems across divisions, across geographies, all sending the data into a central data lake. Well, that's from a network scalability, from a network utilization perspective, very complex, large data volumes. But then there's also the complexity of just simply managing a system like that. And I'm quite happy to say that with the HVR technology, there is a single console that the customer can use in order to visualize what is going on in an environment like this. And then lastly, but certainly not least, how to make this secure and manageable, because the data lake technology is moving to the cloud, as so many technologies are. And with that, data gets sent across the public internet, and that data has to be secure. There's a lot of systems that are still running on-prem. With data moving into the cloud, it's got to be encrypted, it's got to be secure, and then, of course, from a manageability perspective, you want automated monitoring. Nobody has to be babysitting all of these data flows flowing into that central system. So now I use the use case of prescriptive analytics for industrial manufacturing. I strongly believe, or actually I know for a fact, that in any particular industry you'll find use cases of prescriptive analytics, whether it's making your customers more happy in a retail environment, whether it's the finance industry, whether it's healthcare, logistics, government, insurance. Any particular industry will have examples for prescriptive analytics. So what I would leave the audience with is think about some of the examples of what could prescriptive analytics mean for your organization, and and then how would you potentially enable an environment like that? Like what data sources do you need, and then eventually think about what technologies would you be deploying. Now, if that's something of interest and you want to get in touch with HVR to potentially think about how you can integrate some of those technologies with the least impact, feel free to reach out to us, contact us, go to our website, look at some of the online resources that we provide. And with that, I'm going to hand it back to you, Stephen. Thank you.
Thank you very much, Mark. At this point, we're going to move on to questions from our viewers today. And the first question is for Danny. Danny, how do you deal with mapping dynamic or schemaless data sources into the architecture?
That's a great question. Always, the schema-less and dynamic schema has been one of the challenges and why a lot of that technology has sat to the side, if you will, in traditional data architectures or architectures that are hybrid in nature. From our perspective, we attack it two different ways because the data in those structures really has two key perspectives that are important. One, how does it relate to the business? One, how does it relate to the technology? And then how do we map between them? Our capability is to manage the technology using the native structure and approach that database. So something like a MongoDB that is has documented or document-based and collection-based type databases. We will give you the capability to reverse engineer them natively or create them natively, deploy them natively, and then map them back to more of a traditional logical model that really, abstracts out of the technology and then presents that data back to the business in a way that makes sense to the business. So it's really about giving each domain the view that they want, mapping those views effectively together, and then allowing those to be integrated out based on the need and the requirement of that integration. So if it's something on the business side, we'll generally go through traditional data models that allow people to describe and understand them as they relate to the business. As for the technologists, we provide them with that capability to work with it in its native format and then map that back to the enterprise.
Understood. Thanks, Danny. Bruce, our next question is for you. Do I have to know SQL or learn some other language to use Looker?
Thanks, Stephen. That's a great question and a common concern. So Looker relies on an underlying data model that's developed by your data analysts. And in the data model, the data analysts are defining all the relationships between data. They're presenting the data to users in a way that makes it easier for them to understand and access. And when users access the data, it's strictly point and click. They point at the data that they're interested in, and in the background, Looker is building queries for them. And those queries are specifically based on the dialect of the database that you're using. So all the queries that we generate are optimized based on the underlying database.
Understood. Thanks, Bruce. Mark, our next question is for you. Does HVR get involved with capturing IoT data?
Great question, Stephen. And the answer is, well, and sometimes we do, and sometimes we don't. And it really depends on where does the IoT data come from and what's the destination of the IoT data. Arguably, IoT data is easier to deal with than some of the data that comes out of traditional systems where there's transactional consistency and transaction boundaries that organizations are really worried about. Whereas IoT data, it's not necessarily the individual data points, but more the patterns between them that are really important. It's often like if I think about traditional technology speak, it's like an insert-only kind of a stream of new data points. Whereas in some cases, or in many cases, the traditional applications are more insert, update, delete kind of workloads, and the current state of that information is important. Whereas from a IoT perspective, it's the stream, it's the patterns between those that gets that is what organizations are interested in. Now, we are absolutely smack in the middle of capturing some IoT data. There is data, well, even in the case of the manufacturer, there's data that sensor-generated data from machinery that gets stored or that gets collected in a central data store that is then subsequently captured and propagated by our technology. But in some cases, again, depending on the various technology choices, we don't get involved. But it's certainly a great question.
Understood. Thanks, Mark. Okay, Danny, back to you. question is, ERwin's EDA approach looks like it would take some heavy lifting up front before you see results. How do you deal with the volume of discovery and overhead required to initiate this type of approach?
Sorry, a great question, Stephen. Really, the answer is it doesn't take a lot of heavy lifting. First, in terms of the data assets that you have, we automate the discovery of those data assets and the creation of detailed models that represent those things. But more importantly, the overarching approach is very agile at its core. We don't enforce a lot of heavy enterprise architecture methodology. We support all of the major frameworks, but really our tool is made to be quite agile in that you can start with very thin slices and look at what's important to your business. Again, going back to the goals, motivations, and strategies that are in your business, looking at what parts of the business is impacted, what data supports that part of the business, and then allows you to work at that, build on that iteratively, and create that sort of annuity of architecture as you go through. Our solution is a SaaS-based solution. It takes nothing to get up and started, and our modeling approach, very much, with Archimate, is very easy to do in terms of it's very quick. It doesn't take a lot of depth to be able to get those representation and then start the collaboration with all of the different stakeholders and start working on it. So, getting the solution up and getting access to it when you want it, providing you the capability to really create that architecture in an agile way and do that iteratively over time based on the priorities in your organization, and then maintaining that and building on that architecture and building those links as it makes sense. So it's not like you have to have your whole enterprise defined before you can start working on it. You can very much look at what's key and critical to you, which area of the business, which applications, what goals and what deficiencies in your data architecture do you want to address today, and then be able to quickly get a picture of that, how that's integrated, be able to make those decisions, prove those decisions out, and then grow on that as each new project and each new slice becomes apparent to you.
Understood. Thanks, Danny. Bruce, our next question is for you. How long does it take to build a model so that people can start accessing the data?
Thanks, Stephen. So we have a video online that you can watch that's called Database to Dashboard. And it shows you the process of going from a database with no integration to Looker to being able to produce reports. And the full video takes about 15 minutes. So the process is very quick. You connect to your database. Looker will import information about the tables and infer relationships between them. And you can start building reports right away. Your analysts are going to spend time defining key business metrics within the model. So making sure that there's a single unified definition for how all of your key business metrics are presented to your users. So as an example, if a user came to you and said they needed a report that showed the lifetime value of a customer, in the old way of working, you would produce a single report, hand it to this single user, and then anybody else that needed to know information about lifetime value of a customer would have to come to you. But with the Looker data model, the data analyst just defines how lifetime value of a customer is calculated within the data model, and then that becomes a piece of data that's available for anybody to pick and report on at any time.
Understood. Thanks, Bruce. Mark, our next question is for you. How can HVR clients be sure their data is correctly moved into the destination?
Great question, Stephen. So the answer to the question is that HVR actually provides a technology or provides a function in the technology to compare the data after it was moved. So when you think about continuous data integration and you think about the life cycle or how to start with continuous data integration, HVR's single offering actually provides a technology that allows organizations to go end to end by defining continuous data integration in a heterogeneous environment. And that starts with if the destination has the concept of tables, the definition of those tables that will be created based on existing definitions of tables, mapping data types automatically, etc., and performing any transformations that were defined along with the definition. Then performing the initial load, doing the incremental, ongoing, continuous change data capture and integration, but then also providing the ability to do the compare of the data and even repairing the data should that be necessary. And I think we think about some of the data governance and some of the aspects that came up during the presentation. I think it's very important that we realize like the value of a compare function like that, because in the end we consolidate all of this data into sources. The business users are a creature of habit, and they don't necessarily want to change the spreadsheet that they're looking at. So we got to develop that trust into this modern data architecture, into this central system, to ensure that users will shift from their spreadsheet to the central data model, that we're all looking at the same data source, that we stop arguing about the data that we're looking at, but rather start taking action and making decisions. So the compare function is really important, and as part of our single offering, it's part of the solution.
Understood. Thanks, Mark. Our next question is more general in nature, but perhaps it's something all three of you can weigh in on. Question from a viewer today. My company has data spanning 2 decades stored in basic folders and files. I'm tasked with creating a data architecture. Where do I start? Danny, do you want to start with this?
I'm going to assume folders and files are those paper folders and files. Again, I think from our perspective, it's really what are you trying to achieve? How are you trying to transform your business based on this move? Is it just a pure automation perspective? And then really identifying at the highest level what is in those folders and files, what's the nature of that data, and then finding out where what's the best technology to potentially store that data. Is that something that's a good candidate for a data lake or something like that? And again, it's really about understanding the impact on the business that will guide you towards, and the requirements behind this change that you're wanting to make, or this need to build a data architecture. Being able to identify that and ensure that you stay true to that will give you a lot of the answers to what that data architecture should look at. But the first thing I would say is to really, at a very high level, start to create a model that says what is the nature of that data, what is it, what different things are in there, and then start looking at how I can start to handle those things individually or en masse, depending on the investigation that you find, or the answers you find through that investigation.
Understood. Thanks, Danny. Bruce, would you like to weigh in?
Sure, and I'm gonna assume that we're talking about folders and files on their PC rather than paper. So, what I would recommend is that you go with a sort of a stepwise refinement process. We have lots of partners that we work with who have undertaken very similar ventures. And one of the things that you can do that makes it really simple is you can just move that data into block storage on the cloud. And there are lots of technologies that will allow you to access the data from those files as though it was stored in a database. So that's going to give you the opportunity to use some of these high-powered tools to access the data, see what's there, how you want to work with it, and from there you can move it into databases if it's all reasonably structured data. But I think the first step would be to get it into a place where you can access it, work with it, decide what it is you want to do with that data, how much help it's going to be for you to be able to compare data from today to data 2 years ago. And then once you've decided what you want to do with the data, it's very easy to move it from block storage into a database or some other analytics type engine.
Understood. Thanks, Bruce. And Mark, did you have any thoughts?
Certainly I have some thoughts. A lot of the thoughts were already covered by Bruce and Danny. But yeah, in the end, I think what's really important is think about the business case, think about the business users, and look at the value that they can obtain out of the data that's sitting there in arguably difficult to access data, and then based on the data sources that are there, sure, it's files and folders, etc. But is it somewhat structured data? Is it more text-oriented data? What is the kind of data that we're looking at? And then also start thinking about, well, what is the kind of analytics that we would run against this? What is really going back to what is the use case? Are we going to do more text analytics? Are we going to do sentiment analysis? Or are we looking at numbers that are stored in spreadsheets on files where we really want to aggregate some of those numbers and do some more comparative analysis like what Bruce was talking about? I think the technology is then derived based on, well, what is the kind of technology that we're looking at. I think block storage, as Bruce mentioned, is a good starting point potentially. But yeah, if there is some structure to the data, then there's probably ways to store the data to make access to it a little easier than just on block storage, or get a little bit more bang for the buck from a scalability and accessibility perspective, and then start from there. I think there's various technologies that could play a role here, but at a high level, if we just start with files and folders on file systems, then that's where I would start.
Understood. Thanks, Mark. Okay, Danny, we have another question for you. Does the new version of your tool set support capturing business processes, and what ways do you support automated capturing of that information?
Yeah, thanks, Stephen. Actually, we do not reverse engineer processes today similar that we would in terms of schema or unstructured dynamic schema on the data side. We do have a number of capabilities to pull in processes that have been defined in other tools. So anything from legacy process type tools to something that's been described in Excel or something like that. We can parse that, pull those in, and accelerate the creation of that. One of the things that we're building and continually looking at on our platform is APIs and connectors for all the different environments that are out there. We support standard business process modeling notations, which means that we're a step away from looking at different business process automation type solutions and things like that, and being able to pull from that. But today, no, but definitely on the roadmap.
Understood. Thanks, Danny. Bruce, our next question is for you. Is Looker leaning towards being a data virtualization tool with reporting/analytics capabilities, or is it more of a BI tool set with analytics capabilities?
Thanks, Stephen. So we don't do any data movement at Looker. Data is stored completely in your database. We query the data, so we're not moving, storing, abstracting any of the data. So it is very lightweight. It's all web-based, and we do business intelligence and analytics, but we definitely consider ourselves to be more of a full data platform.
Understood. Thanks for clarifying, Bruce. We have time for one more question. Mark, I'm going to give the question to you as a vendor that deals with data integration both on-premise and in the cloud. Question is, what are the benefits of moving all your data to the cloud versus keeping it on local storage?
That's a great question, and I think that's not a decision that, from a technology perspective, we often get involved in, because the technology simply enables the data movement wherever it needs to go. But I do think, from an organizational perspective, I hear our clients talk about increased flexibility in the cloud. It's a pay-as-you-go model in most clouds. So it's much easier to try out different technologies, and if you think about the pace at which new technologies get delivered on a cloud platform, I think it's a great way to get, well, very convenient access to some of those technologies. And then also, I think what I hear a lot of organizations discuss is the flexibility of allocating resources in the cloud versus on-prem, where on-prem is like, oh, we need to submit a request, and then a purchase order needs to get generated, and there's many levels of approvals that need to go through that, and on and on. So literally it takes, in some cases, just months in order to retrieve, to be able to get an environment allocated that then can be used for analytics purposes or whatever it is. The cloud doesn't necessarily have a similar monolithic process, and well, depending on how the organization is defined, I certainly hear my clients very much refreshed from being outside of that loop of very lengthy requests and decisions. So really, when it comes down to why would I go to the cloud versus on-prem, I think it's more of a business decision about flexibility, about pay-as-you-go.
Understood. Thanks, Mark. That is all the time we have for questions today. We apologize that we weren't able to get to all your questions, but as I stated earlier, all questions will be answered via email. I'd like to thank our speakers today, Danny Sandwell, Senior Product Marketing Manager at ERwin Inc., Bruce Sandell, Senior Sales Engineer, Alliances at Looker, and Mark Vandeville, Chief Technology Officer at HVR. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived, and you'll receive an email tomorrow once the archive is posted. Plus, if you would like a PDF of the presentation, you can click on the resource icon at the bottom of the console. Now, as we stated earlier, just for participating in today's event, someone would win a $100 American Express gift card, and the winner today is William Adam. William, we will be in touch via email so you can claim your prize. Thank you, everyone, for joining us today, and we hope to see you again soon.